Hello everyone, my name is Akila Nandu, and in this past 1 month I've been learning web development under Professor Gomez, and it's been a wonderful journey so far. And in this video tutorial I'm going to be explaining all the major concepts that I have learned in full stack application. And this video is going to have 5 major parts. So first I'm going to be giving a general mapping idea of how the entire full stack application works together, and then I'm going to be giving a very broad explanation of all the major components of a full stack application, and then I'm going to be giving a very deep explanation about APIs and how they work, because that is what I found and what I struggle with the most to understand. And then I'm going to be also giving and I'll be ending the video with a very live coding demonstration. And I've also included a very creative hack that I found useful to memorize and understand full stack applications in general. So stay with me till the end of the video and let's move on to the first part.
Before I continue, I just want to quickly introduce my website SkillBridge, because I'll be using it as a reference throughout this explanation video. So SkillBridge is a student collaboration platform where students can share their skills, find teammates, and connect for class projects, hackathons, research ideas, or side projects. So the homepage basically introduces the platform and explains the main purpose of the website. And the teammates page basically shows the student profiles where users can search for teammates, view their skills, availability, and then connect with the people they might want to collaborate with. So whenever I mention forms, profiles, API routes, or database records, I'll sometimes use SkillBridge as an example to make the concepts easier to understand. And so I'm showing this to you now so you know what I'm talking about in the later part of this video. Okay, so over here in the teammates directory, we have created various profiles. So there is a search filter button where you can just filter it through keywords, skills, city, country, team opening if you're still looking for a teammate or found teammate needed, and then availability, which are on weekends, weekdays, weeknights, flexible, etc. And then preferred role and what's the team status if you're looking for a teammate, open to help, or already in work. And over here I basically created a small how it works part of the page because it seemed a little bit empty on the side. And so yeah, if you go to add my profile, you'll be able to add your name, email, profile, owner code. So the major part of this website is the profile owner code, without which you cannot edit, delete, or mark as teammate accepted for the teammate profile that you posted. And then you can type out the skills that you can teach or the skills that you want to learn, and then you can also add a short note over here. And then when you press the apply button, it goes directly here, which would it has an already drafted email. And then if you open the email draft, it would basically go to Outlook, where it will draft the email you want to send to. I'm just gonna scroll it down so that you can see the entire mail, and it will send it to that person. So moving back, this is my website, and again I'll be using this in the later part of the video. So over here I'll start with the big picture using this concept map. Then I'll explain the major concepts, then I'll go deeper into one specific concept, and finally I'll show a very small live coding demo. So for this first part, I want to explain web development as one connected system, not as separate topics. Sometimes when we learn HTML, CSS, JavaScript, Node, Express, and MongoDB separately, they can feel like different things. But in a real project, all of them work together, so this map shows how the pieces basically connect. So at the top, we start with the user or the student. The user is the person who basically interacts with the website. They might click buttons, fill out a form, search for teammates, post a skill, or basically they use the website. The user does not directly see the backend or the database. They only interact with what appears in the browser. And next, the user opens the website through a web browser like Chrome, Safari, or Edge. The browser is important because it is the place where the front end basically runs. When we write HTML, CSS, and front-end JavaScript, the browser reads those files and turns them into a page that the user can actually see and use. And now we can move on to the front end. The front end is the visual and the interactive part of the website. This is everything the user sees on the screen. HTML gives the page structure, for example, headings, paragraphs, buttons, forms, images, sections. They are all created using HTML. CSS controls how the page looks. It handles the colors, the spacings, layouts, fonts, responsiveness, and the overall design. JavaScript basically adds behavior, and it makes the page interactive, like responding to button clicks, form submissions, searches, filters, and updates. And the DOM is also part of this front end idea. The DOM is the browser's live version of the web page, and JavaScript can use the DOM to change what appears on the page. For example, when a new skill profile card appears, like after submitting a form, like I'm just relating it according to my website, which is SkillBridge, which we had to submit for a project too. And over there, when a new skill profile appears after submitting a form, JavaScript is updating the DOM. But a modern website is usually not only just front end. If we want to save information permanently, we need the front end to communicate with the back end. So this is where the API calls come in. API calls are like messages between the front end and the back end. The front end uses something like fetch to send a request. The request might ask for data, create new data, update existing data, or basically delete something. For example, in the Project 2 website that I created called SkillBridge, a student would fill out a form to create a skill profile. The front end collects that information and sends it through an API call. The data is usually sent as JSON, which is basically a format that looks very similar to JavaScript objects. This makes it very easy for the front end and back end to understand each other. And now we reach to the back end. The back end is the server side part of the application. So this is where we use the Node.js and Express. Node.js lets us run JavaScript outside the browser, like on the server, and Express makes it easier to create like routes and APIs. Route is like a specific address that handles a specific request. For example, a get route can return all the profiles, and a post route can create a new profile. The backend is very important because it controls the logic of the app. It decides what happens when a request comes in. It can check the data, validate it, and error messages, and then send error messages. And then it connects to the database and sends a response back to the front end. So after the backend, we have the database, which is very important. In our class projects, we used MongoDB. So MongoDB stores data permanently. This is what allows the app to remember information even after the page refreshes or when the server basically restarts. For example, like according to my project 2 website, for example, user profiles, teammate requests, project posts, and other records can also be stored in MongoDB basically. So the overall flow is that the user interacts with the front end. The front end sends an API request, and then the back end receives it. Receives the request. The back end talks to the database, and then the response comes back to the front end. The front end then updates the page so the user can see the result. And finally, we have the deployment, which is basically when we run a project locally. It only works on our own computer, like it gives source host and localhost, sorry. So it only works on our own computer, usually through localhost. And deployment is what makes the app public. So till then it will be private and only we can view it, we can use it. So after we make it public, everybody will be able to use the website. When we deploy using a website like render, other people can open the website using a real URL. So this is the final step that turns any of our projects into something others can actually use. So the main idea of this entire map is that a full stack web application is a conversation. The user talks to the browser shows the front end, the front end talks to the backend through API calls, and the backend talks to the database, then the response travels back again to the user and then updates what the user sees. So this is why I kind of like to summarize full stack web development like a website. uh, like a website is basically a conversation between the user, the browser, the server, and the database. So once we understand that conversation, all the individual concepts starts to make much more sense. Okay, so now that I have explained the big picture using the concept map, I'm going to go through the main concepts one by one. The goal of this section is not just to define each word. I want to explain how each concept has a role in building a full stack web application. In web development, we usually start with a part the user can see, which is the front end. Then we connect that front end to a backend. The backend handles the logic and communicates with the database. And finally, deployment makes the application public. So in this section, I'm going to be explaining HTML, CSS, JavaScript, the DOM, APIs, Node.js, Express, MongoDB, and deployment. So these are not separate random topics. They are layers that work together to turn an idea into a working application. So the big idea is that the website is a system. Okay. So when we first learn web development, it is easy to think a website is just a page with image, texts, buttons, etc. But modern websites are much more than that. They are interactive systems where the users can send information, receive information, update content, and sometimes even collaborate with other users. So the front end is the part where the user sees. This includes the layout, buttons, forms, colors, and interactions, like how I already mentioned. The backend is the part that the user does not directly see. It handles requests, logic, and communication with the database. The database then stores the information so that it does not disappear when the page refreshes. And for example, in a project like the one that I made before, which is in my other YouTube video, you can check that out in my description. So in that project, it is called SkillBridge, and basically a student can create a skill profile or post a teammate request. That action starts on the front end, but the data has to travel to the back end and get saved in the database. So without getting saved in the database, all the data, it wouldn't work out very well. So the main idea is that the front end shows and collects the information, the back end processes it, and the database stores it, and the deployment makes everything accessible online. So HTML basically stands for hypertext markup language. It is basically the structure of a website. I like to think of HTML as the skeleton of the website because it tells the browser what content should exist on the page. For example, headings, paragraphs, links, buttons, information, forms, lists, and sections, they are all created using HTML. So HTML is not mainly about design or how beautiful or how wonderful the website is. It is about meaning and organization. So if I add one h1 tag, I am telling the browser that this is the main heading. And then if I add a button tag, I am saying this part of the page is something that the user can click. If I add a form, I am creating a place where the user can enter information. And in my project SkillBridge, HTML was used to create the home page, profile forms, search box, teammate cards, and also navigation links. So without the HTML, there is no clear structure for the browser to show. So CSS and JavaScript mainly depend on the HTML because they need elements to style and interact with. So HTML is basically the foundation of the page. Next we move on to CSS. So CSS basically stands for cascading style sheets. CSS basically controls how the page looks. So if HTML is the skeleton, CSS is the design or like clothing on a person and like presentation. Basically it is how the website looks. It controls the colors, fonts, spacing, borders, shadows, alignments, page layouts, and responsiveness. For example, if I want my website to have a yellow B theme and rounded cards, clean buttons, very nice spacing, and a layout that works on both laptop and phone screens, I use CSS. So CSS is also important for the user experience. So if a user doesn't like how the website looks, he or she may not use them. They might not use them. So a website can technically work with only HTML, but it may not feel professional or very easy to use. Good CSS helps the user understand where to look, what to click, and how the page is organized and structured. So in a full stack project, CSS does not handle data or backend logic, but it is still a very important part of the website. The way a website looks affects whether the user can trust it and whether they can use it comfortably. So CSS answers the question, how should the website look and feel? So moving on to the JavaScript. So the JavaScript basically adds interactivity and logic to the front end. HTML gives the page structure, CSS makes it look good, but the JavaScript makes it respond to the user. For example, when a user, like when I click a button, JavaScript can run code. When a user submits a form, JavaScript can collect the input and give it to MongoDB. When a user searches for something, JavaScript can filter the results. When new data comes from the backend, JavaScript basically displays it on the page. So in the project that I was creating, JavaScript could handle things like loading profiles, showing search results, opening any apply form, validating user input, or updating the number of teammates needed. So JavaScript also has to be used very carefully, because if the code is messy, the website becomes very difficult to maintain. That is why we organize code into functions. Like we use very clear variable names and separate front-end behavior from back-end logic. So JavaScript answers the question, what should happen when the user interacts with the page? So next we move on to the APIs and JSON. Next we move on to the DOM. So the DOM stands for Document Object Model, and the DOM is the browser's live version of the HTML page. When the browser loads an HTML file, it turns that file into a tree-like structure that JavaScript can access and change. This is very, very important because JavaScript does not just work with a HTML file as very plain text. It works with DOM elements. So for example, if I have a div with an ID called say profile container, JavaScript can find that div and insert a new profile card inside it. So if I have a button, JavaScript can add an event listener to it. If I have a message area, JavaScript can change its text to show success or error messages. So the DOM connects the HTML structure with the JavaScript behavior. So moving on to the APIs and JSON. So APIs are one of the very most important parts of the full stack web application, because API is like a bridge between the front end and the back end. The front end should not directly talk to the database. Instead, it basically sends a request to the backend through API routes. So in front end JavaScript, we commonly use fetch to make these requests. Using fetch can basically send a request to a URL, wait for a response, and then use the data that comes back. So APIs are like the communication channel of a full stack app. So without APIs, the front end would be isolated from the backend. Moving on to the Node.js part. So Node.js basically lets us run JavaScript outside the browser. Normally JavaScript is known as a browser language because it runs in Chrome or Safari or whatever web browser that you have. But Node.js allows the JavaScript to run on the server too. This is very useful because we can use JavaScript for both frontend and backend development. So on the backend, Node.js can receive requests, process data, connect to databases, read environment variables, and also send responses. So in the project that I've been working on, the Node.js is what allows the server to exist. The frontend runs in the browser, but the backend runs using Node.js. This is a very important shift because a website is no longer just files being opened by a browser. It becomes an application with a server that can make decisions. So, the MongoDB. There is also the Express part of the slide. So, the Express is a backend framework built on top of Node.js. Node.js gives us the ability to run JavaScript on the server, but Express makes it very much easier to build web APIs. So with Express, we can create routes. A route is like a specific path that handles a specific kind of request. For example, a get route can return data, a post route can create data, a put route can update data, and a delete route can basically remove data. So Express is like the traffic controller of the backend. It receives requests, sends them to a correct route, and then returns the correct response. So now we come to the MongoDB part. So MongoDB is the database layer. A database is very important because it stores the information permanently. And only if we store the data in JavaScript variables on the front end, the data appears when the page refreshes, or else it won't be available anymore and it would disappear. If we want real users to create and view data later, we need a database. So MongoDB is a NoSQL database. So instead of storing information in tables like traditional SQL databases, MongoDB stores information as documents. So MongoDB works very well with JavaScript because the data structure feels very familiar. The frontend sends JSON, the backend works with JavaScript objects, and MongoDB stores document-like data. So the last part of making a website is the deployment. So deployment is the step that makes the project public. When we build a project locally, we usually run it on a local host. That means it works on our own computer, but other people cannot easily access it. So deployment takes the project and puts it online using a platform like Render. So once deployed, the website gets a public URL. This means that your classmates or professors or any real user can open the app from their own devices and use it. And deployment also forces us to think about the real world issues. For example, the app needs environment variables, a working database connection, correct routes, and proper static file handling. So without all of these, the website would not be accessible by the public. So in class project, deployment is important because it proves that the app is not just working locally. It shows the project can actually run as a public web application. Okay. And to bring everything together, each concept basically has a clear role. HTML creates the structure, CSS makes the structure look good, JavaScript adds the interaction, the DOM basically allows JavaScript to update the visible pages, and fetch sends API requests from the front end to the backend. Node.js basically runs JavaScript on the server, Express creates the backend routes, MongoDB stores the data permanently, and deployment makes the full application public. So a full stack application works because these layers communicate with each other. For example, a user fills out a form, HTML provides the form, the CSS makes it look clean and beautiful for the user, so the user likes using it. The JavaScript collects the input, fetch sends the data to an express route, express handles the request using Node.js, and then MongoDB basically saves the data that the user gave it. Then the backend sends a JSON response. JavaScript receives that response and updates the DOM so the user sees the result. That is basically the full stack cycle. So the main takeaway is that web development is not just about writing, separate files. It is about building a connected system where the front end, back end, database, and deployment where they all work together. So now moving on, in order to make you guys understand in a very simple way, which is very easy to remember and would maybe stick into your mind, I wanted to explain the full stack web development using a beehive analogy. And since my project 2 is called SkillBridge and it uses a bee style theme, I thought this would be a very fun and memorable way to explain how all the layers of a full stack application basically work together. So in this image, the full stack web app is shown as the main beehive in the center. And the reason I chose a hive is because a hive is not just one object, it is a system. So every part has a role and the hive only works when all the parts work together. And this is very similar to a full stack web application. So let's start with the first part, the bees. Here the bees represent the users or the students. So in a project like mine, SkillBridge, the users are students who come to the website to find teammates, share skills, or collaborate on projects. The users are the reason the whole system exists. So without the users, the website is just code sitting there, without anybody to use it. So the users interact with the website by clicking buttons, filling out forms, searching, reading profiles, and applying to collaborate. So the second part is the flowers. So in this analogy, the flowers represent the front end. The front end is the part that users directly interact with. So the forms, buttons, cards, search bars, navigation links, page layouts, they're all like flowers. Just like how bees goes to flowers to collect nectar, users go to the front end to give information or to get information. So for example, when a student fills out a form to create a skill profile, they are basically interacting with the front end. The front end has to be very clear, easy to use, and very visually friendly, or else a user would not choose it. So that is why HTML, CSS, and JavaScript are so important here. HTML gives the front end structure, the CSS makes it look good, and the JavaScript makes it interactive. The third part are the worker bees. So the worker bees represent API routes. I like this part of the analogy because the API routes are always carrying information between different parts of the app. They carry data from the front end to the back end and then they bring responses back. So for example, when someone submits a profile, the front end basically sends that data through an API request. The API route receives that request and knows what to do with it. So if the user is creating a profile, the API route sends that data to be saved. And if the user is loading profiles, the API route brings that data back. So over here, the worker bees are basically like messengers. They do not just sit in one place; they move information around the system. The fourth part is the honeycomb cells. So over here, honeycomb cells represent database records like MongoDB. In a real hive, honeycomb cells store honey and they support the structure of the hive. So in a web application, the database stores that important information. And in my project, of which the link is in the description again, each database record could be a student profile, a skill listing, or a collaboration request. So MongoDB stores this information as documents. That means the data does not disappear when the page refreshes. It can be saved, searched, updated, and displayed later. So the database is what basically gives the app memory. Without a database, the app would forget everything after the user leaves or refreshes the page, meaning there would be no honey. The fifth part is the honey, the very sweet part of the system. Okay, so honey represents the useful results that the user gets from the application. So the final result is not just data. The final result is that the it can be the main major function of the project or the website. So in my project, the final result is that the students can find teammates, discover useful skills, and start collaborating. So honey, which is the results, basically gives you basically completes the aim or the objective of why the entire web page was made. And now if we look at the whole image, we can see the full process. The bees or the users interact with the flowers, which are the front end. The front end sends information through worker bees, which are the API routes. Which are the API routes? The API routes then connect to the honeycomb cells, which are storage areas which contain honey or the results. And then the stored data becomes useful results, which are represented by honey. So this makes the full stack idea a little bit easier to remember. I thought it would, a full stack app is not just a front end, like not just a backend or not just a database. So it is a well connected system. Every part of the hive has a role. The bees bring activity, the flowers provide interaction, the worker bees carry information, the honeycomb stores the data, and the honey is the final useful outcome. So that is the same way a full stack web application works. The user interacts with the front end communicates with the back end works with the database, and the user receives something useful in return. So basically the very creative takeaway in this is that a full stack application is like a beehive. It works best when every layer has a very clear role and when all the layers communicate properly. Okay, so for the deep explanation part, I am going to be focusing on one of the most important full stack ideas, which is the API journey. And I chose this topic for the deep dive part of the video because it took me basically a lot of time to understand it, and I just wanted to make it easier for you guys too. Okay, so yeah, I want to make this fun by treating one skill profile, which is in my SkillBridge website from project 2, a skill profile like it is going on a road trip. It starts when a user clicks submit, then JavaScript sends it using fetch, the Express receives it on the backend, the MongoDB stores it, and then the JSON comes back to the browser. And by the end, the page updates and the user sees this result. So this is the story of how one small action becomes a complete full stack flow. Okay, so let us start with a story. Okay, imagine a student fills out a SkillBridge profile. They type their name, skill, availability, and meeting preference into a form. So at this point, the data is only in the browser. If we do not send it to a backend or database, it is not really permanent and it might disappear when the page refreshes. So the main problem is, how do we safely move data from a form in the browser into a database like MongoDB? That is exactly what the API flow solves. So the first step happens on the front end. So the JavaScript listens for a submit event, and when the user presses the submit button, the JavaScript can read the form fields using the DOM. Then it creates a clean object like profile data. This object is much easier for the app to send and understand. So instead of thinking of the form as random boxes on a page, the JavaScript turns those boxes into very structured data. And this is the first transformation in the journey. So the user input becomes a JavaScript object. Next, the frontend has to send the object to the backend, and this is where the fetch comes in. I personally like to think of fetch as a courier bee. It carries the data from the browser to the server. So for creating something new, we usually we usually use a post request. And the request includes the URL, the method, headers that say the data is JSON and the body which contains the actual profile data. And one important detail is JSON stringify. So the browser turns the JavaScript object into a JSON string so it can travel across the network properly. So what does Express do here? Now the request reaches the backend. Express is listening for routes, and each route is like a label door. If the request is a post request to /API skill profiles, the Express sends it to a matching route handler, and inside that route, the REQ body contains the data that came from the front end. This is where the backend can check whether required fields exist, whether the data makes sense, and then decides what to do next. So Express is kind of like a traffic controller for the backend requests. Okay. So moving on. Once the backend has the data, it can save it to MongoDB. In my as I mentioned before, in my bee metaphor, MongoDB is the honeycomb. Each cell stores one useful piece of information. And in MongoDB, each record is a document that looks very similar to a JSON object. And this works nicely with JavaScript apps because the shape of the data feels very familiar. And saving data in MongoDB means the profile can survive refreshes, it can be shown to other users, and the app becomes a real full stack application instead of just some static page. So after MongoDB saves the data, the backend does not just go silent. It sends a response back to the front end, usually as a JSON. The response can include a success message and the saved profile. On the front end, JavaScript reads that response using response.json. Then it can update the page. It might show a success message, clear the form, or add the new profile card to the list. To the user, it feels like one smooth click, but behind the scenes, all of this stuff happens. A very important question here is why not let the front end directly connect to the database? So the answer to this question is safety and organization. The front end is visible to the user, so we should not put database logic or secrets there. Because the backend acts like a gatekeeper. It checks requests, applies rules, and decides what data can be saved or returned. And this separation also makes the project very easy to maintain. So if the design changes, we update the front end, and if the data rules change, we update the back end. If the storage changes, we update the database layer. It's that easy. So yeah, for the live demo, I will keep the code very small, and it's in another part of this same video. So the point is not to build a whole project in 5 minutes. The point is to show the journey in a very small scale, like this flowchart. So first I will create a new fake profiles in an array. Then I will create a get route in Express that returns those profiles as JSON. And after that, the front end will use this fetch to request the data. And finally, the JavaScript will loop through the result and display profile cards on the page. So this very small demo represents the same architecture used by big architectures. And finally, to close the deep explanation, this is the entire loop. So the user submits a form, the JavaScript collects the data, fetch sends it to the backend, and Express matches the route and handles the request. MongoDB basically stores the data. The backend returns JSON. The front end reads that JSON and updates the DOM. So the big takeaway is that APIs are the bridge that allow the front end, backend, and database to work together as one full stack application. When this flow is clear, building larger apps becomes very much less confusing. Now I want to go a little deeper and show what an API request looks like in actual code. So this slide focuses on one backend route, which is the post/API/skill profiles. So in a full stack app, post is usually used when the front end wants to create something new. So in this example, the user is creating a new SkillBridge profile. And when the user fills out a form on the front end and then clicks submit, the front end sends that particular data to this route. And that data comes into the backend through the REQ body. And here we are pulling out fields like name, skill, and availability through the REQ body. So these values are the information the user typed into that form. So the next important part is the validation. So before saving anything to the database, the backend checks if important fields are missing. So in this example, if the name or skill is missing, the backend sends back a 400 response. A 400 status basically means the request was bad or basically incomplete. So this is important because we do not want to save empty or broken data into MongoDB. So if the data is valid, the backend creates a new profile using where is that? Okay. So yeah, creates a new profile using skillprofile.create over here. So this is the part where the data gets saved into MongoDB as a document. And after saving, the backend sends back a 201 status. So over here, 201 status basically means something was successfully created. It also sends the saved profile back as a JSON so the front end can use it. And then at the bottom, we can also see that there is also error handling. So if something goes wrong on the server, like the database connection fails, the backend returns a 500 status. That basically tells us the problem is on the server side, but not because the user typed something wrong. So this entire code basically shows the full API pattern, which is that it receives the request, reads the data, validates it, saves it to the database, and then returns a response, and while also handling errors. So the main idea is that the API route acts like a gatekeeper between the front end and the database. The front end does not directly touch MongoDB. Instead, it sends a structured request to Express, and the Express decides what should happen. So this is why APIs are so important in full stack development. They keep the app basically organized, safer, and easier to manage. Now I'm going to do a small live coding demo to show the same full stack idea in a very simple way. So instead of rebuilding the entire SkillBridge project that I did, I'm gonna be making a very mini version of it. So the goal here is to show how the front end basically asks the backend for data, and how Express responds with JSON, and how JavaScript displays that data on the page. So this is the same basic pattern used in larger full stack projects like SkillBridge. So we're here in package.json, and before coding I already set up a basic node project and then installed Express. So in package.json I have type as module so I can use import syntax, and I also added a start script, so instead of typing node server.js every single time, I can just run npm start in the terminal. And Express is listed as a dependency because I'm using it to create the backend server and the API route. So over here, first I'm starting with the backend. So I import Express, and I have created an Express app. So Express helps me create backend routes, and then I set the port to 3000 so the project can run locally on my computer. And Express JSON lets the backend understand the JSON data. I also use express.static public, which tells the express to serve my front-end files from the public folder. So my HTML and JavaScript files will be available through the browser. So for this mini demo, I'm gonna be using a simple array instead of MongoDB, where each object represents one SkillBridge profile. So over here, I'm gonna be typing constant skill files equal to, and I'm gonna be adding the name. I'm gonna be adding my own name here. And okay, next can be skill. So my skill, I'm gonna be giving React. Let me just make the R capital, and then I'm gonna be giving my availability as weekends. Okay, that's one. I'm gonna be giving another one with name as okay, for example, Santosh, who is my teammate. We worked on the SkillBridge website together, and then for him, I'm gonna be giving MongoDB, and then I'm gonna give his availability on the evenings. And then I'm going to be creating another profile with my skill. Maya can be really good at UI design. And then I'm going to set her availability to just phrase. So in the real SkillBridge profile, this data would, come from the MongoDB. But for this short live demo, an array basically makes the idea easier to see. And the important idea is that the backend has some data and the front end will request that particular data through an API. So now I'm gonna be creating a get root called API/skills, which is GPT /API/skills. And key this. Doing that. So over here, get means the front end is asking to read the data. So when this route is called, Express basically sends back the skill profiles array as JSON, and this route is the API bridge, so the front end does not directly touch the data. So instead it asks this backend route for the data. And finally, I'm going to be using app.listen to start the server. So this means the backend is now waiting for requests on localhost port 3000. So I'm going to give listen. So that's done. And once I run this file, Express will serve the front end page and also respond to API requests. So I'm gonna save this. So now we're gonna be creating the front end. So this page is intentionally very simple. It has a heading, a button, and an empty div. So the buttons will be used to load the profiles. So I'm gonna be HTML, and then I'm gonna be giving HTML and API. Okay. Just give me a second. Yep. And then we're gonna have a head. So inside the head, we're gonna be creating a meta. So yep, meta capsule, and then so for the title, I'm gonna be giving okay, yeah, SkillBridge live demo, if that makes sense. Title is done, head is done. So now we're gonna be moving on to the body part. So inside the body, I'm gonna be creating a h1, and then I'm just gonna type SkillBridge profiles inside it, and then I'm gonna be creating a button. ID, it can be sorry, I forgot the people. ID can be yeah, low profile button. That's on it. And then below that, we're gonna be creating a div, and I'm gonna give div ID is gonna be okay, I'm gonna give profile container here. And then below that, we're gonna be giving a script. So in the script, src script.js script. Below that body is closed, and then I'm gonna make sure to close my HTML as well. So yeah, so the buttons will be used to load the profiles. The empty div is where the JavaScript will insert the profile information, and at the bottom I connect the script.js file which will handle the button click and fetch the data from the backend. And now I'm gonna be moving to the front end JavaScript. So here I select the button and the profile container using the DOM, and the DOM lets JavaScript access and change elements on the webpage. So now JavaScript knows which button to listen to and where to display the profiles. And then below that, I'm gonna be adding an event listener to the button. So this means when the user this sends a request from the frontend to the backend API route that I created earlier. And the backend sends back JSON data, and I convert that response using response.json. And then I clear the container so the profiles do not repeat if the button is clicked multiple times. After that, I loop through each profile. So for each profile, I create a new div, add the name, skill, and availability, and then append it to the page. So this is the front end receiving backend data and then updating the DOM. Okay, so now I'm gonna be starting the terminal, and I'm gonna start the server using npm start. So this would be my web page. Okay. So as you can see, it shows the terminal shows the server is running at localhost port 3000, and I'll keep this terminal open because the server needs to stay running while I test the website. So yeah, now I have opened the localhost 3000 in my browser, and this is the front end page being served by Express from the public folder. And right now the page only shows the heading and the load profiles button over here, and the profile container is empty because I have not clicked the button yet. And I'm going to be clicking the load profiles button. So now when I click the load profiles button, the JavaScript runs. So the front end sends a fetch request to /API/skills, and the backend receives that request and then runs the express get route and sends back the skill profile data as JSON. So then JavaScript takes that JSON and then it loops it through and creates HTML elements and then displays them on the page. So this basically shows the complete flow. Button click, and then it goes to the fetch request, and then the backend API routes, and then JSON response, and then DOM support. So I'm gonna show you what the API looks like. So yeah, it shows pretty print, name, Akilan, skill, and then it shows Santosh and then his skills, and then Maya and then her skills, and then the availabilities on frame. So this shows the raw JSON response from the backend. A normal user would typically, not usually visit this page, but the front end uses this data behind the scenes. So this proves that the backend API route is working correctly, and the browser page with the button is the user-friendly version. So without this, the user would not want to see this, but if the user sees this, he would like to use the website. And this JSON page is the raw, raw data version. So yeah, this small demo is a very simplified version of what happens in my the other website, which is SkillBridge. I'll be showing you that webpage too. I'll just wait for it to load. So in the real project, the profile data would not come from the hard-coded array, it would come from the MongoDB. But the pattern is basically the same here. So yeah, over here the profiles are loading from MongoDB and not from where we created now. But the pattern is the same, and the front end sends the request and the backend handles that route, and the database provides or stores that data, and then the front end updates what the user sees. So even though this demo is small, it basically shows us the core idea of what happens behind a full stack web application. So to summarize this live coding demo, I created a small Express backend, added an API route that returns SkillBridge profile data, and then used front-end JavaScript with fetch to request that data, and then I displayed that data on the page using the DOM. And over here, the important takeaway is that full stack development is about connecting layers, and the front end asks for that data, the backend responds with JSON, and the front end basically updates the page. So this is the core pattern behind many full stack web applications. So after the demo is done, I can stop the server using Control C in the terminal.
And just like that, we have come to the end of the video. Thank you guys for staying with me throughout this video. I hope you guys found this useful, and thank you and have a